on here. So WIPS, great. So, what we're looking at here are some innovations that we've come up with to deal with the new standards and new practices. Great new standards, things evolve. WPA3, awesome, right? We're going to use 11W protected management frame, but that really breaks WIPS in a very important way. I mean, you think if you have like Wi-Fi Pineapple with OWE or any other device, doing a man-in-the-middle attack with OWE. In the past, you would basically send DOTs, right, to prevent that connection, so you could prevent your clients from straying or getting, falling prey to that type of attack. With 11W, those DOTs aren't going to work, right? Of course, there are over-the-wire prevention techniques. We can do that. But with a man-in-the-middle attack, somebody has a Wi-Fi Pineapple in a backpack or something like that, you obviously can't do over-the-wire prevention techniques because they're not on the wire. It's not like a rogue AP, right? It's disconnected. So you have to do over-the-air. So you have to rely on over-the-air prevention techniques. And de-authentication is not going to work in the presence of protected management frame, right? So how do you do that? So we've come up with a way, and we're announcing this today. I don't think it's been announced previously. We've actually come up with a way, and it's patent pending, of preventing those associations or detecting them and then, basically preventing them in a precise surgical way. So we're able to actually then get the client to, stop communicating with the honeypot or just an external AP. You may have a policy that says, when these clients are corporate clients, they should never connect to anything else, right? Or you might have a policy that says, hey, corporate clients, you shouldn't connect to a honeypot. That's a good policy. So we have a way of doing that. So we have a little demo. It's not super polished, but let's just take a look here. So let me just, before I start the demo, we got two laptops. The laptop on the left side is the corporate asset. The laptop on the right side is some other external asset. So or laptop is not part of the corporate. In the back, hiding there, lurking in the back, is Arista AP, and it's going to use this multifunction radio to do this detection and prevention. Really important that you have a multifunction radio if you want to do over-the-air prevention, right? Because you're not able to take your access radios, like serve clients and then go off channel or whatever to do prevention effectively. So you really do need a multifunction radio, or you have to turn a number of your APs into full-time sensors, quote unquote.
It's a corporate asset based on the MAC address?
In this case, this is a corporate asset. It's an authenticated or authorized client because it previously connected to an authorized AP. So the way that we determine if clients are authorized or not is if they connect to authorized APs. And we authorized APs, basically, that's part of the installation process. When you add APs and SSIDs to your network, you authorize them and you nail down how they're supposed to be configured. And when a client connects to that authorized AP, then it becomes an authorized client. So it's based on behavior in terms of which clients are authorized or which clients are external or which clients are rogue clients, et cetera.
It had to go through some onboarding process?
For the APs. For the APs, you tell the system which SSIDs, which APs are authorized. Okay. And you can nail down, like, oh, you have to use WPA3, you have to use...
So if I'm using Agni, like your Cloud NAC, if I'm using Agni, can that somehow hook into this, like the client, authorized client, and to make sure that,
It could, but so far this is all being done. It's part native of CVQ, the Wi-Fi solution.
Mm-hmm.
Yeah, but in the future, you could, basically, we could have some policies that, in terms of quarantining. But this happens even without Agni. So I want to point out quickly, we have it. You see the link authentication is WPA3 SAE, just to show you that it is using protected management frame in this little demo before we hit the start button. And what we're going to see is that the client on the left, both clients will connect to this SSID called corporate. It's a spoofed SSID. And you'll notice the BSSID is 46A0 in the last two octets for both these clients. So we'll show you the clients connecting, and the client on the left is under attack because it's connecting to the spoofed SSID. Then prevention will kick in. The client will get knocked off that network, and then hopefully it will come back home. Now that's up to the client, right? You can kick it off. You can, you can prevent it from connected to the honeypot, but the client has to decide that it wants to come back to its authorized AP. Right? So some clients are better at that than others. So I'm gonna, move it along a little bit. So here, so now both clients are connected to the honeypot. You see the 46A0, 46A0. And the reason why we have two clients is we want to point out how it's surgical, right? We're not taking out all clients connected to the honeypot. We could, right? But in this case, we're just concerned with the corporate client, the authorized client. And the DAuth should be happening, not DAuth, the technique that we're using. And you might say, well, what is this technique? Mm-hmm. Well, it's patent pending, so I'll anticipate the question. And so we will share the patent number as we get a little bit further along, so you'll get all the details. So now the client has been disconnected from the attacker. And then over a little bit of time, now you see the BSSID. Now it comes back to that's the actual BSSID, the 1150 in the last two octets. But you see the other client's still 46A0 corporate, same SSID.
Does your patent approach, so this covers the case of when the client is authorized. Are you working on a method to detect rogue access points where one of your engineers has gone down to RIP Fries, but and bought like a Linksys AP and plugged it in under his desk, and then he's connecting a unauthorized corporate device to the corporate network through?
We do that as well, right? Yeah, we can prevent. So if that AP is physically connected to the network, we don't have to do over-the-air prevention techniques. In that case, we would do on-the-wire prevention techniques. Yeah, that's easy. Yeah. Okay, I'm going to move on to the quickly. I know we got to wrap up here, so move on to the next slide. Another thing we're doing is we are for non-compliant APs. So we work as an overlay, and so we can have non-compliant APs that are not managed by the CVQ. They're managed by some third-party controller or whatever, cloud management system. And we can basically, if we have a new classification, if we see an AP that's capable of doing, WPA3, it's using 6 gigahertz, but it's not using WPA3, it's using WPA2 or, open. We can label it as non-compliant, and we can also do prevention on that AP as well, automatically. Automatic, right? That's really important to think about because we're moving to a fully automated on the network connectivity issues, network performance issues. We've been doing full automation on WIPS for over 10 years. And if you think about that, the stakes are higher. If you get WIPS wrong, right, you can get sued by your neighbor and fined by your regulatory domain. And so we were very cautious before we went fully automated there, and we're being also cautious, and as we get to full automation and AI ops. Another one, real quick, transition mode. So we have a policy basically when we set up our policies for our access points, we can say disallow transition mode. So the AP would be flagged as, basically misconfigured if somebody were to spin up an SSID and enable transition mode. And clients, we know which clients are capable of supporting WPA3, and if a client connects with WPA2 instead of WPA3 or open instead of OWE, we'll flag it as a misbehaving client. We can prevent that. And then lastly, MAC randomization. This is for if you have environments where they say no random MACs. We can basically set that policy to alert that some random MACs are on the network. And when there's a policy, say no, no random MACs allowed. That's pretty much it.